Hi guys, so here's our notes for the sine law. By the end of these, you should be able to identify when you can use the sine law and actually use it to solve some trigonometry problems. Okay, so first off, the nice thing about the sine law is that it works for all triangles, not just right triangles. So this is nice because you do not need to have a 90-degree angle in order to use it like you do for Pythagoras or sine, cos, and tan ratios. Now, how you can tell if you can use the sine law is if you have an angle, let's say here's our angle A. If you have an angle and you know its opposite side and you're finding anything else on your triangle, you can use the sine law. So as long as you have an angle and its opposite side, you are good to go. And what the sine law is the following formula. So it is sine A, so sine of angle A over side A equals sine of angle B over side B. And you'll be looking for one of these things. So you'll either be looking for sine A, or either trying to find an angle, so trying to find A, or you're trying to find B, or you're trying to find this side or this side. So basically, we are going to set it up as a ratio of sine of an angle over its opposite side. So as long as you know one half of this, so either like one angle and its opposite side, you can use this formula. And there are a couple of terms that you might come up against, sorry, in some of the questions. The first one is angle of elevation, and it is just the angle that when I'm looking up at something, it's the angle that I'm looking up at it for. And my angle of depression is if I'm looking down at something. So looking out and then down. So my horizontal line down will be my angle of depression. And the biggest thing there is make sure that you are looking at from the horizontal down, not this one right here. This is not an angle of depression between like your vertical and your line of sight. It's from looking out across the ocean and then looking down for this example when you're looking at that boat. Okay, let's use some sine law. So for our first example, we are determining angle B. So the first thing that I'll usually do is if I don't have a picture, I'll draw it. And if I do have a drawing, I will label it. So we draw and label. Okay, so here's triangle ABC. I'm looking for angle B. I have B's side. Here's angle C, and I have C's side. Now, here's the thing. As soon as I have an angle and its opposite side, I know that I can use the sine law. So I can write the formula for my sine law. So in this case, I'm going to use some of the variables that I actually have instead of just A's and B's, which is what my sine law in general has. So I am using C. So I'm going to have, I know sine C, I know angle C, and I know side C. So these are the things that I know. And what am I trying to find? So let's take a look here. So I have side B, and I want to find angle B. So sine of, I'm looking for angle B over side B. And then I'm going to substitute my values in. So subbing in my numbers, I get C, angle C is 63 degrees. So make sure your angles always go inside of with your sines. So sine of 63 degrees. So here's my angle. My opposite side is 5.5 and equals sine of B. So that's what I'm looking for. I'm looking for angle B. So it just stays as it is. And its opposite side is 4.7. Now you might notice that this is just going to be, when we're solving, it's going to be some cross multiplication. So however you like to solve cross multiplication problems, either multiplying across and going from there, or if you want to do my cheater's magic square way, we're looking for this box. It's fine that it's sine B. We're still looking for the thing that's in this box. So in order to find that, it'll be, take a look, I will be dividing by the 5.5. It'll go on the bottom, and I multiply the other two, right? So I will do sine B is the thing I'm looking for, so that box, so equals, it'll be 4.7 times sine of 63 degrees divided by 5.5. Now don't freak out with that sine B yet, okay? So it's still just my sine of B equals, and then when you do 4.7 times sine of 63 divided by 5.5, make sure you're doing this in your calculator, because depending on what calculator you have, you might have to do some extra steps here. So for example, you can do 4.7 times sine 63 equals, and then divided by 5.5 equals again. Okay. Or you might need to make sure you have, if you want to do it all in one step, make sure you have a bracket after your sine 63, depending on your kind of calculator. So basically, work it out, figure out your calculator steps, or ask me when I'm back or in class, so that when you do this calculation, you end up getting 0.7614005, blah, 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 blah. Okay, or 0.55. So just I'm going to write 4 decimal places here. So make sure you're getting this number. Okay, now sine of b equals this. So in order to figure out what b actually is, I need to get rid of that sine, and I get rid of it by doing its inverse operation. Okay, so the inverse of sine is sine to the -1, so that gets rid of that. I just have b left, and what I do to one side, I have to do to the other. Okay, so to figure out what my angle B is, it'll be sine to the -1 of 0.7614, whatever that number was that we got from this calculation. Okay, and that is 49.588, so on and so forth, degrees. Kind of looks like a 13, that's a B. There you go. Okay, so we get that our angle B is 49, just to one decimal place, 0.6 degrees. So just like when we were finding angles using sine, cos, and tan, remember that when you are going to be finding an angle using the sine law, you will have to sine to the -1 in order to find those angles. So don't forget that. Maybe write it on your front page there, as a reminder for yourself. Okay? So second question, we have a triangle, QRS. Now, if I'm not given any drawing, I'm going to make one. I like looking at things visually. So here we go. So here is Q, R, and S. Okay, so this will be little q, here's little r, here's little s. Right. Now, side Q is 14. Okay. Angle Q is 110 degrees. Angle R right here is 20 degrees. And angle S is 50 degrees. Right here. Okay. Now, I want to find side R and side S, so the two sides that I do not know. Now, when I'm doing this, if I take a look at my triangle, I have an angle and its opposite side. Take a look at that so I know I can use my sine law. Okay, so sine, in this case, Q, and its opposite side, I know. Okay, so I'm just going to have those right there. Now, let's take a look at what I'm going to be finding. All right, so it doesn't matter which one you find first, since we know they're opposite angles. Okay, so let's say we're going to find R. Let's find R first. Okay, so here is side R. Here is angle R. So across from each other. So let's make sure they're set up correctly. So sine of my angle R over its opposite side. So making sure our angle and opposite side are lining up. And then just substituting in. Okay, so sine of Q. So Q is 110 degrees. Divided by side Q is 14, then equals sine of my angle R is 20 degrees, so goes in there, and then I don't know side R, that's what I'm trying to find. Alrighty. Okay, now cross multiply however you like to. I'll just quickly magic square it. So looking for this, so R, so it'll be an R equals. I'll be dividing by the one across and multiplying the other two. So R equals, solving for that box, 14 times sine of 20 degrees divided by sine of 110 degrees, right? And into our calculator, making sure that you are also getting a value of 5.0955, blah, 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 blah. All right, so if you're not, you might have to make sure you are getting some brackets in here, maybe if you're trying to do it all at once. Or yeah, do 14 times sine 20 equals divided by sine 110 might help. Or make sure that your calculator first off is in degrees mode. If not, if it's in radians or gradians, like rad or grad, that's going to give you an incorrect answer as well. So making sure that in your calculator you are getting the same thing as me. Right, so let's just round that to one decimal place. So r equals 5.1, and since we don't have any units, we're good. You'll notice that there is no sign next to it, so we don't have to sign to the -1 it. So when you're finding sides, you do not have to use that sign to the -1 button. Okay, so r equals 5.1. Now to figure out s, we just do the same thing, except right here, instead of sine r over r, we'll have sine s over s. Okay, so I'm just going to move things around, equals, then here we'll have s and its opposite side right there. It's getting all messy, but you see what I'm doing. Okay, so sine s over side s. So angle s, opposite side, and substituting in. So this stays the same. So sine q over q equals, and sine of s, so s is 50 degrees, divided by trying to find its side. All right, so looking for this, so we'll divide by the one across and multiply the other two. So s equals 14 times sine of 50 degrees divided by sine of 110 degrees. Once again, into your calculator, making sure you get what I do. That should be 11.4129, blah, blah, blah. Okay, so side s to one decimal place is 11.4. And once again, I did not give you any units for this, so it won't have any units. But if it was something like centimeters or meters or miles or kilometers, you would put those units there as well. All right, so we get r is 5.1, s is 11.4. So in summary, in order to use your sine law, make sure that you have an angle and its opposite side. If you have if you know two angles, you'll be able to find out that third one using SMAT 180. So that still works. And the sine law will work for all triangles, including right triangles. So it doesn't just work for right triangles like sine, cos, and tan and Pythagoras. You can use it for everything as long as you know an angle and its opposite side. Okay, there is one last example to do. And I'm going to do that in a different video since this one's already overly long. Workplace math people, you don't have to worry about this last example. If you don't want to, you won't have anything like this. And foundations people, I would only ever give a question like this on an exam as like a bonus question. I'm not going to make you do this just regularly. Okay, bye.